So going back to the outline right here, and just finishing a few topics on presentation about files and paths. Okay, so this is the presentation we've used the last week, chapter 18 in the book, files, paths, directories, and other metadata related stuff. So you can see that we've been covering some things. We've come across the sample code here, which says that we can try displaying the content of a subdirectory. Okay, and I think we've left off with the sample, so let me take a look at the sample. So this sample was working with the path. Let me see, so I have a path here. Let me take a look at this path so I can refresh my memory regarding the content of it. I'm jumping to my file manager and going to the specific spot. So I seem to have a subdirectory which is empty, and also a directory which contains my file2.txt, and in my subdirectory I will create a couple more files. New text file. I'll say this is my file3.txt. Okay, so this is my file3, and just so that we can see more than one file, we'll just create another file named my file4.txt. So the challenge is, I think, is to how can you display a content of the directory, and how can you if necessary navigate into subfolders and come back. Okay, so there could be challenges like this, and so following this we can basically go to the data, and I can also create a new folder and name it subfolder or subdir, to be consistent, subdir2, right? So this is like I have two subdirectories, and right there likewise I will continue with what I've done, my file4. So the next one is going to be yet another file named my file5, and my file6, which will be yet another two items .txt. So if I know where I am, and this is my location, then I can go to the command line right here and say go to this place. Okay, and here I can say display the tree. Okay, so the tree command on Windows here shows me that I have basically from the current directory I have two subdirectories, and you know, I'm going to work towards the similar problem solution in my own code, trying to recognize directories and files, and also recognize the need to occasionally go into a subdirectory if I have to. So let's take a look at what the sample does. The sample from this slide, which is slide number 14 in our presentation regarding paths and files. Okay, so this specific one is being, I think, modified by us, and so this is what it does. Basically, I have this hard-coded path to a subdirectory. All right, the name of this subdirectory is data, and it's located somewhere on my C drive. Okay, so then I convert the string, this is just a text string. I convert it to a path, which is a natural first step into, you know, the process of working with an artifacts or elements of the file system that I have. Okay, so the first thing that I do is that I check whether the directory exists, and if it's a directory. So if it's a directory, I know that I can then go through that directory and try locating individual items in that directory. So look what I do. I take my directory path and convert it to absolute path, and I print it. Then I say, okay, this location on my drive, this subdirectory, may contain some files, and I print files. And what I do is that in order for us to navigate through items in a directory, you need something called directory stream. Okay, directory stream. So we say directory stream, and the way you create this directory stream, of course, you create directory stream for a valid directory, right? So directory path is an object of the path class, and it already exists, and I already validated it. I already know it's a directory because I made my check, finding a way in this section of Java library, finding a way to check for directory and that it exists. And so now I create this directory stream, right? And I say that the result of this iteration through items in the directory, or what I would like it to be, is that each time it gives me something, okay, it will be giving me another path item, right? So right now, if you think about it, what I have so far, okay, let's just kind of like run a quick demonstration of this on the side, right? So if I try to envision this, what I have is a subfolder, okay, named data, okay, that was the name of the subfolder. That subfolder contains couple of other subdirectories, right? It's called subdir over here, and I know that this subdir contains couple of files. One of them is named myfile.txt. Okay, so this is one file right there. Another one was called myfile2.txt in the same subdirectory, so there are a couple of files over there, right? Then I had another subdirectory which I created today and call it subdir2, okay, just similar to this one. This one contained another two files, which was called myfile3, myfile4.txt, all right? And then I also had a subdirectory named subdirectory3, okay, just like this. And that too also had two files in that structure. So clearly this is a hierarchical structure. I would consider this is my entry point into this subsystem. And I think my challenge is to incrementally write the program carefully, write the program which is capable of act like a visitor, which visits this subdirectory and then finds these files, then says, oh, I am done at this level, let's go up and go to the next level and see what's here and find these files, and then say, oh, we're done with this level, so let's go back and go up and find another subdirectory and continue this until we exhaust an entire substructure. Now, I also would like to point out that it could be a possibility, right? So if I take this as an example, right here, okay, it may be possible to have another subdirectory off of this, okay, just I apologize for my kind of reckless drawing here, but I'll try to do my best, right? So at this point, a list of these files could be that not only files are at the subdirectory level, but also that there is this subdirectory there as well, right? So there could be more levels to go down to, and I'm trying to design a successful recursive procedure which will act accordingly by visiting these subdirectories. So and find the files. Okay, so let's give this a try and see what happens right now. So we just, again, I say that the directory stream class is yet another helper class, which is part of the paths and files family, which is a helper with iteration through the directory. And if you look at this loop right here, this is a standard loop where we say, I would like to ask the file system to visit every single item in this specific directory that I'm looking at. And so it's going to give me path P every time it finds another item. So look what I do. There is a check for the regular file, or there's a check for the directory. So I will be just assuming that anytime I have a regular file, I will simply print the file name. And so instead of saying file right here, okay, instead of saying file, what I can do is I can print it here. Okay, just move this line down here and say print file, right? So recognize that this is a file. And likewise, if it's a directory, basically print that this is a directory. And I'm already trying to do this on this line, so I'll just say, I'll simplify it, get rid of unnecessary code here, and just say this is a directory right there. Right, so this is a directory, and essentially print it like this and get rid of this additional comments. So I start at the data level, and I will try to run this. Okay, so it takes me through this level, hopefully, right? So it should run. And it says basically your directory, which is named data, which is located elsewhere, right, on this long path into my file system, and it finds two files, file.txt, file2.txt, and subdir and subdir2. I don't think these are this is unexpected, because that's exactly the picture, right, this picture here, that I'm getting when I'm looking at the content of my data, right? So that's exactly the picture. Now notice that the operating system is positioning the directories, the directories at the top of this listing, right? So if I wanted to do the same thing, you see that what I'm getting here in my a routine that I'm trying to write to visit these items. It finds them in historical order as they were created, so the directories are not automatically returned at the beginning of this list. Rather, they appear wherever they do physically appear in a listing of that directory. So in some instances it can be acceptable, sometimes it cannot be acceptable. Right now my only plan is to visit, be able to successfully visit all the subdirectories. So therefore I will ignore this order. I'm okay. As long as I'm finding everything, I'm okay with this idea. So okay, now notice that I'm already printing a directory every time I sort of like run this program. So I begin to think that this entire section of the code right here, right? This entire section where it says directory such and such contains files and other directories, right? I would like to make it a separate method. Why? Because I would like to make multiple calls into it, because it allows me to successfully find items in my directory. So what I'm going to do is that I'm going to essentially leave alone this if statement at the main method level, but everything that's inside this if statement, okay, which says, all right, here's your directory. Let me actually get rid of some extra empty lines to make it more, condensed. right? So this entire section where once again we say, here's the directory, print the absolute path to the directory, then say, here's your file, here's your directory, and print the entire content of it. So now, of course, this needs to be enclosed in try and catch, otherwise, there could be exceptions thrown, so we have to protect ourselves from those, checked exceptions. So we just routinely write those try and catch statements so that we stay safe with what we do with respect to the actual content. But then I'm just going to Control X and get rid of this, and instead make it look like something that says visit directory, right? Visit directory. Okay, so visit directory is going to take a path such as dir path that I already have as an input parameter. Okay, so let me create this method at the top of my class, and obviously I'm going to make it perhaps, why not, I can make it public static void. I don't think it needs to return anything. I don't expect the need to return anything, and of course it's going to be named visit directory. And so visiting the directory simply involves what I already do, right? So I'm just properly going to mark the ending of my visit directory, this public static method, which does all of this, and all I need is this path, dir path, to essentially do this. So with this change, nothing really has changed. All that I did was I created a separate method which I used to visit my directory. Okay, so notice that my visit directory prints the name of the directory at the top. So therefore, first of all, let me compile and run it just with one single change. So the good news is that nothing has changed, right? I'm visiting this directory. I'm saying, okay, this is where I am right now, and these are the items that I find. Okay, so now I think that instead of doing this, as soon as I find a directory, right? And the way I do this, I say, you gave me the path. I'd like to find out if this is a regular file, and if it's a file, I just print its name. Okay. Otherwise, what I'd like to do is, instead of using this system out print line and print this, right? Instead, what I'd like to do, what I'd like to do is comment this out, and instead just say visit this specific path, right? So just say, hey, if I was able to do it with the original directory path, why can't I visit a subdirectory directly from this situation where I already found an item that looks like another directory, right? So let's save that and run it again and see what happens. So look what happens this time. It goes into the data, right? Then it finds a couple of files. Then, of course, it finds the subdir, but instead of printing subdir, this time I call visit directory again, but this time I pass it the path to this location on disk. So it successfully finds a couple of files, just like that, right? Then it just runs out of items, right? It just runs out of items. This loop terminates, and I naturally return from visiting the subdirectory and go back to to this, to continue iteration through items of my data subdirectory, and that finds another subdirectory which is called subdir2, right? So then, of course, I'm finding a way to print the absolute path, the complete path to this location, and guess what I do? I continue printing items because I call visit directory recursively. So we say that this is an example of a recursive function, because what it does, or recursive method or function, function would be normally called in C or C++, here we call them methods. So visit directory calls itself, okay? So it's a method that calls itself under certain conditions. If it finds an item which looks exactly like a directory, it calls itself. And this is an example of a recursive method.